In C and C++, you can use the enum statement to define new groupings or new types of a sort that can be very convenient for using as names for things that you might have otherwise hard-coded in and had to remember as values within your program. So we use the enum keyword, and then we provide the name for the type. This one, for example, is color. And then with that type name, we use the same rules as variable names or class names. It is defining a new type. It's not a composite type of storing multiple different types of things like a class might be. It's creating something from scratch. So just like a bool can store 0 or 1 and is treated as true or false, the same is true for your enum, that you're defining names for those different particular values, and then you can define later particular behavior that goes with them. Inside of the enum's brackets, you give a comma-separated list of names for each of the things that enum groups together. These also have the same rules as variable names. The first name will by default refer to the value 0 unless you specify otherwise, and then each later one is 1 higher than the previous one. You should typically use all lowercase or all capitals for these so that they don't look like a class name. You can use names in your code then to stand in for those values like red or blue or cyan or green. You can specify a particular value for one of those that's out of sequence. For example, if you wanted the sequence to start at something higher than 0 for red, we could have defined that to be some higher number. It restarts the numbering from that assigned value for anything that follows. So here we have red becoming 0, blue becoming 1, cyan, because it's hard-coded, becoming 6, and green, which follows it, becoming 7. You can use this to replace arbitrary numbers you might have put into your code elsewhere, where you might have passed a 0 or a 1 or a 2 for something to indicate different conditions that your program was encountering. Like the complexity example here, where 0 was being used to refer to linear complexity, 1 was being used to refer to quadratic complexity, and so on. We could create an enum of complexity classes with names that are reasonable, like linear, quadratic, cubic, and so on. And then when we write a switch or an if statement or use those values otherwise, we're able to just use those names, linear and quadratic, and so on. And our code is much more readable because you don't have to remember a particular number. You don't have to rely on comments documenting what those particular numbers were indicating. We just have one list of all of the possible values related to it. And if we needed to change a value or add something to our enum or things like that, we change it in one place. If we decide, for example, in the situation before, that we wanted a constant level for our complexity, we could just add that to the enum. We don't have to go through all of our code and find all of the places where 0 had been used for linear and change it. It is also type checked, meaning that we can use enums as arguments in functions. We could say this takes a color, and that would refer to the color enum, and then the compiler will complain if someone uses a value that's not valid. In the case of our color enum, if they used 8 for it, that would not be a valid value for a color, and so it would error at compile time. We can easily add, remove, or reassign those values, as I mentioned, adding more complexity classes, removing one, things like that. Sometimes it's useful to maintain a parallel array of labels of strings to label the enum values, so that if linear is the first item in our enum, then we could create an array of strings where the word linear, the string linear, is available at index 0, and so on for the others. And then when someone gives us linear as the complexity class, we could print out that linear was the word associated with it and label our output. They're also, in a more advanced case, very useful for flags when we want to specify multiple features about a thing, like in the case of animals, that animal may have claws and fangs, or it may be a predator and can fly. And so we can specify binary values that each use a different bit in our enum, and then if someone specifies 2 of those values, they can be combined using binary operators into one number that shows the correct bits for that. And we'll be able to do comparisons where we say if one flag and another flag are both true, then we'll do a certain behavior. If only one of those flags was true, then we do a different behavior, and so on. So this allows a lot more complex combinations of how our program could behave. This is very common, for example, in the Unix file system. We've seen examples where we needed the executable flag to be set for files, and those are done using bits, like in the example before. So it's convenient to be able to specify these new bit values, these new flags. We don't have to create each one as a constant int and figure out how to do the correct math between them or anything like that. It makes our code much more easy to read, that someone can see these flags are being used, and it provides, again, type safety if these flags are used as parameters to functions. But we have to watch out because operators on those will return ints, and it may not be able to be as easily checked as the examples of the other enums that we looked at before.